In the last section, we added and subtracted polynomials. Well, today we're going to multiply polynomials. So this is going to be a little bit of a visual of what it looks like to multiply a monomial, one term, times a binomial, two terms. So we're going to use the area of a rectangle to do that. So recall that area is equal to length times width. So on this problem, we might say that the length, or the width maybe, is equal to 3. So 3. And then the length is made up of x plus 2. So it would be 3 times x plus 2. So that would be a representation of finding the area of that rectangle. So now what we're going to do is we're going to think about it in terms of the smaller rectangles. So here I'm going to have, when I talk about the area of this one, I have x times 3, which is going to be 3x. And then when I talk about the area of the one on the right side, so here, so this is still a 3 over here, the area is going to be 2 times 3, which is 6. So you can see then if we add those two areas together, it would be represented by 3x plus 6. So you can see our distributive property, 3 times x is 3x, and 3 times 2 is 6. All right, so here's some examples multiplying monomials times binomials. And it's getting a little tougher because we're going to have to do some thinking about y times y. So when I distribute, I have 3y times y minus, and then I have 3y times 8. So y times y, we're adding our exponents. When we multiply, we add our exponents. 1 plus 1 is 2. So this is 3y to the second minus 24y. When I distribute this next one on b, I have negative 5x times x. And then I have a negative 5x times a negative 3. So I have a negative times a negative on that. So the first one, negative 5x times x, is going to give me a negative 5x to the second power. And now I'm going to have a negative times a negative, which gives me a positive 15x. You do not need to write this line right there. I'm just kind of doing it to just demonstrate that. You're going to say negative 5x times x is negative 5x squared. And a negative times a negative is positive 15x. So let's do one more there. We'll do this one. We'll do this one over here. So this time when I multiply 2x squared times 3x, I get 6. X squared times x, I add the exponents 2 plus 1 and get x to the third. And then positive times a negative is negative. 2 times 7 is 14. X squared times x to the fourth. I'm going to add those exponents and get a 6. Now thinking back to our last section, we can't add these because they're not like terms because they have a different variable exponent combination. So none of these could we simplify any further. You might give D a try. I'll come back and I'll do it in class, next class. Example 2, again, multiply and simplify. So this time you see it's not simple. We have a multiplication, x times x minus 1, addition, and then 5 times x minus 1. So PEMDAS would tell us I need to do the multiplication before I can do that addition, which is going to be done last. So I'm going to multiply, which means distribute here. So I'm going to get x to the second minus x. And then positive 5 times x is 5x. And a positive 5 times a negative 1 is going to be a negative 5. So notice how it ends up looking right there with no parentheses. Now once I do that, I need to combine like terms. So the x squared doesn't have another one like it, so x squared. But now I have a negative 5x and a positive 5x. They're like terms because they both have the same variables. And so I'm going to add a negative 1 plus 5, add those coefficients, and get a positive 4x. And then the minus 5. at the end. B, same situation, have some multiplication and more multiplication and subtraction in the middle. So I'm going to multiply first, m squared times m to the third. Positive is going to give me a positive, m squared times 3 is 3m squared. So see the way that looks. Now I have a negative 4 times m. That's going to leave me with negative 4m. And a negative 4 times a positive 3 is a negative 12. Combine like terms. Here I have an m to the third, and m to the second, an m, and a constant, so nothing combines. So we'll end this video right now. Okay, just kidding. So on second thought, I want to come back and do this last one. A times a is a to the second. A times positive 7a is going to be a plus 7a. This time there's nothing to multiply here, which is why I wanted to show this. So it's like an understood negative 1. So I'm multiplying a negative 1 times a, which is a negative a, and a negative 1 times a positive 7, which gives me a negative 7. So even if I don't have a number, I still have to distribute that minus sign and eliminate the parentheses. Combining like terms here, I have a squared plus 7 minus 1 gives me a 6a minus 7. And now I will stop for real.